Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 6 of a unit System of Particles and Rotational Motion. So let's begin with today's class. In today's class we are going to discuss about the torque. So let's look what torque is, how does it apply, and what are the significances of the torque. So let's first define moment of force, or we can say torque. We can say that torque or moment of force about a point is defined as the product of the force and the perpendicular distance of the point of application of the force from that point. So let's suppose a consider a particle at P of, look at this, this is the torque. So what we can say, torque that is equals to force multiplied by perpendicular distance. Let's suppose this is the point P, and on this point a force F is acting, and this is the angle theta. So what we can do is that this is the R, and we are going to have a two perpendicular components of R, that are, the one is the R sine theta, while the other is the cos theta. Yes, this is the R cos theta, and this would be the R sine theta. It could be there or it could be here. Yes, so when I write torque is equals to force into perpendicular distance, what I need to write is that this is the force, then to have a perpendicular component of a displacement or a perpendicular distance, it is F into R sine theta in a vector form. In a vector form, that could be written as torque equals to R cross F. So for a torque we can write two things. Torque should be is equals to distance multiplied by perpendicular force, or or we can write torque is equals to force multiplied by perpendicular distance. Either of this must be perpendicular to each other, and this is rotational analogous of force. Let's have a look certain more data. So what whenever we took a perpendicular distance, that perpendicular distance is called as the lever arm or momentum. SI unit of torque is Newton into meter. Dimensional formula, it is m1 l2 t minus 2. Yes, do you remember that it is the same dimensional formula as which other quantities? It is m1 l2 t minus 2. Yes, energy having the same dimensional formula. Energy would be having the same dimensional formula. You can say work done having the same dimensional formula. So energy, work done, torque, all this having the same dimensional formula. It is a vector quantity. Torque is a vector quantity, and the direction of torque is always perpendicular to the plane of rotation. Yes, if if torque produces rotation in anti-clockwise direction, it is taken as a positive, whereas if it produces a rotation in clockwise direction, it is taken as a negative. Let's discuss certain very important points regarding torque. If theta is equals to 0 or 180 degree, the torque equals to 0. Why? Because the force has no turning effect if it is parallel or anti-parallel to the direction of the radius vector about which the body rotates. So if torque equals to Rf sine theta, this is the situation that torque equals to Rf sine theta, within which if theta is equals to 0 degree or theta is equals to 180 degree, then the torque will be the 0. Yes, one more thing, let's look at this. Suppose this is sun and this is one of the planet. Let's take in case of the earth, and earth is rotating around the sun. So if I take the gravitational force, or I should say a torque due to gravitational force of the sun on the earth, what it would be. So what we understood is that this is the position vector from sun to the earth. Its direction is in this direction, and direction of force, that we call as in gravitational force, which will provide me the centripetal force as well. In this situation is will be in this direction. So both are related with each other by an angle of theta, which is equals to 180 degree. So when torque equals to r f sine theta, and this is sine 180 degree, why sine 180 will produce a 0 for us. So this is torque that would be equals to 0. So if theta is equals to 0 degree, torque would be equals to, if theta is equals to 0 degree, then torque equals to rf, which would be the case when the torque is maximum, but this theta should not be a 0, this theta should be 90 degree to make this possible. Yes. So if theta is equals to 90 degree, torque would be equals to rf, and in this situation torque is the maximum. So if the force is applied perpendicularly on the door at the handle, it is easily opened due to maximum torque acting on the door. And if r is equals to 0, if r is equals to 0, I mean if perpendicular distance is 0, then the torque will be 0. This means that when the force acts at the axis of rotation, when the force acts at the axis of rotation or at the point about which torque is taken, the body cannot rotate. We will discuss this points, but you just understand first. We cannot turn a door by applying a forces at the hinges. Yes. So this is the situation. This is the hinge, and this is the door. Now if you are applying a force on this position, if you are applying a force directly on the hinges, you are not going to open that door. This is not possible. But if you are applying a force, let's say here, generally a handle has been kept over there to open or to close the door. Why it has been kept over that? Only because the maximum perpendicular distance you received, the minimum amount of force would be needed to open or close the door. And when this will create a perpendicular distance. So when torque is equals to r f sine theta, if theta is 90 degree, torque would be maximum, which is rf, that we have seen. One more thing, that torque produces angular acceleration on a body that is capable of rotational motion, and the rotational effect of a force is not measured by its magnitude, but is measured by the magnitude of its moment about the given axis. When we say that two or more forces act on a body produces zero net force, but the net torque can be non-zero. It is the cases that, let's say, two forces are acting, and due to this two forces a net force on the body could be zero, but it could have a net zero torque. That means the body will be capable to rotate. I hope this is clear. Yes. So let's just summarize the thing and focus on the practical applications of the torque. We say that torque equals to r into f into sine theta. While saying this, we are focusing that torque should be equals to r multiplied by perpendicular distance, or I should say torque is equals to force multiplied by perpendicular distance. Any one of them, any one of them should be at 90 degree to each other. I hope this is clear. Does it clear first? Great. Now now the second thing is that, let's suppose the situation is something like this. Let's suppose this is the road, and that road is hinged over here. Yes. You are applying a force on this direction. This is force 1. Let's say this is force 2. Let's say this is the force 3. Let's say this as a force 4. Let's say this as a force 5. Let's say this as a force 6. Let's say this as a force of 7. So now you need to find out the torque due to different forces. Let's assume that this distance is L, even this distance is L. Okay, great. Done. So what would be the torque due to different forces? So first let's focus on the torque due to force 3. Look at this. This force is applied on the point where it has been hinged. This is the force. That means torque due to F3 would be equals to 0. Now, how could I come to know this? That here perpendicular distance is 0. One more thing to get an access over it is that always think that whether my force is capable to rotate the body. Please listen this and understood this very carefully. We are applying a torque to rotate a body, not to move a body. To move a body, we are having a force with us. Here we are interested in a rotation of a body, not in a translatory motion of a body. I hope this is clear. So when if you extend, when and when if you extend your vector and it meets to the point where it has been hinged, that means due to that force torque will be 0. So let's understood this. Fy extend it. Yes, it is again going to meet at the point where does it has been hinged. So torque due to Fy would be 0. Why? It is the case where theta is equals to 0. Torque due to F6, again extend this. Yes, it is going to meet the point where it has been hinged. So this is torque due to F6 would be equals to 0. Again, this is the case of theta is equals to 0 degree. Torque due to F4. Yes, extend this. Yes, again it is going to meet the same point. So torque due to F4, even this will be the 0. I hope this is clear. Yes, yes. Now let's work for the torque due to F1. So what you would look, you need to understand that it should be a force multiplied by perpendicular distance. That's it. So what is the force? It is F1. Perpendicular distance, it is L. Which perpendicular distance should I take? I need to take those distance. I need to take those distance from where it has been hinged to the a point where force or application of force is applied. It is as simple as that. Yes. So can you work? Can you work for the torque due to F2? What is the force acting? F2. What is the distance between point of application of force and point of rotation? It's an L. This one. It's a torque is equals to F2 into L. Now torque due to F7. What is it? Yes, F7 is the force and L is the displacement. Anyone remain? Is there anyone? Is there anyone? Yes, F1 is there. F2 written, F3 written, F4 written, F5, F6, F7. Great. Now let's just understand the direction. So hinge from the center and apply F7. Hinge from this and apply F7. In which direction it is rotating? In clockwise or in anti-clockwise? If you observe this very carefully, that it will be moving in the clockwise direction. And if it is moving in clockwise direction, that means torque due to this force is negative. Now let's apply torque due to F2. This is moving in anti-clockwise direction, and when this is moving in anti-clockwise direction, this should be positive. Apply torque due to F1. Yes, it is moving in anti-clockwise direction. If it is moving in anti-clockwise direction, you need to add this. So if they ask net torque, what do you need to write? It's an F1L plus F2L minus F7L. That's it. This Newton into meter. You got this. I hope this is clear. So do you understand? This is very simple terminology for the torque. Always look for the force and perpendicular distance, or rather look for the distance multiplied by perpendicular force. It is as simple as that. Just do this and things will be done. I hope this is clear. Yes, great. Let's work for the one more question. Let's suppose this is the road, and this road is being hinged over here. Yes. Now one of the force is acting at this point. This is F is equals to 10 Newton. One of the force is acting at this point. At this, F is equals to, this is F1, this is F2, this is 5 Newton. One of the force is acting at this position. This is F3 is equals to 20 Newton. One of the force is acting at this point. F4 is equals to, let's say, 10 Newton again. One of the forces acting like this with vertical, it is making an angle of 60 degree, and this force is of 10 Newton. Now let's talk about the distance. This is at 10 meter, this is at 5 meter, and the question says find out net torque on the system shown. So what you need to do, you need to find out the net torque acting on the system. How will you do this? Let's look at this, that our system is hinged at the end of that. So what is torque due to F3? First tell me. Torque due to F3, yes, it has been applied on a same point at where it is hinged, so torque due to F3 would be 0. What about torque due to F4? Even it was the same force, it is the applied at the location where it has been hinged, so torque due to F4 again 0. Now what is torque due to F2? What is torque due to F2? When I apply a force torque due to F2, the situation is this is force multiplied by perpendicular distance. So this is 5 Newton of force multiplied by distance of 5 meter. This would be 25. Yes, we are talking about the direction at the last. Now what is torque due to this force? It's an F1, 10 Newton. So torque due to F1, that would be equals to 10 Newton of force, 10 meter of displacement. It's a 10 into 10, which should be 100. I hope this is clear. And now last, it's an 1 2 3 4. Yes, this is, let's give them a name as an F5. So this is 10 Newton. When I apply the force of 10 Newton, this could be written as 10 cos 60 degree. This is 10 sine 60 degree. So this torque due to Fy, that is equals to 10 cos 60 multiplied by distance, and the distance is of 10 meter. Yes, torque due to this, it's a 10 sine 60 would be 0. So 10 cos 60 is the half multiplied by 10. This is 10 10 100 by 2. This is 15 Newton into meter. I hope this is clear. Now let's talk about the directions due to this torques. So torque due to F2, which is the direction? Torque due to F2. So F2 is the force acting over here, and it is going to rotate the body in the anti-clockwise direction. If it is going to rotate the body in anti-clockwise direction, it should be taken as a positive. Next, torque due to F1. Torque due to F1. This will rotate the body in clockwise direction. And if it is going to rotate the body in clockwise direction, I should take it negative. Now, torque due to Fy. Torque due to Fy. So, it is again going to rotate the body in negative direction. Anti-clockwise direction, I mean. And if it is rotating in the anti-clockwise direction, it should be considered as a positive. Is it clear? Is it clear? So we have two torques that can produce a positive effect, and one torque that can produce a negative effect. That means it is going rotating in clockwise direction. So let's find out the net torque. So the net torque would be equals to 50 Newton meter plus 25 Newton meter minus of 100 Newton meter. This would be a 75 minus 100 Newton meter, that is minus of 25 Newton into meter. When I say minus of 25 Newton meter, that means rod is rotating in clockwise direction. So as the rod is rotating in clockwise direction, this torque is being represented in a negative. I hope this is clear. Is it clear? Is it? Are you sure? Are you? Great. So have you done this? Have you done this? Will you be able to solve this kind of questions? Are you sure? Are you? Great. Now let's work for the next question. Let's say a circular wheel is there and this is the center. This radius is of 10 meter, let's say. One of the force is acting over here. This F1 10 Newton. One of the force is acting over here, such this like this. It's an F2 is equals to 20 Newton. One of the force is acting over here. This is F3, which is equals to 20 Newton. One of the force is acting in this direction. This is acting in this direction. Yes. F4, which is equals to again, let's say 12 Newton. One of the force acting on this. This is F1, F2, F3, F4. This is equals to 60 Newton. Yes. So the question is find net torque acting on the system. This is the requirement. Find out net torque acting on the system. How will you do this? What is to be done? How will you do this? Yes. So the situation is let's write down the torque due to each one everyone. So let's begin with the F1. Torque due to F1, this is equals to 10 into 10, that is equals to 100. Torque due to F2, as it is going to be extended and meeting over here, it's a 0. Same is the case for the torque due to F3. Torque due to F4, it is a 12 into 10, which is 120. Torque due to F5, that is equals to 0. Now we have only net torque due to this two. Yes. So torque due to F1, as it is rotating in the clockwise direction, it is rotating my wheel in the clockwise direction. So if it is rotating in clockwise direction, I should write it as a negative. And this F4 rotating it in anti-clockwise direction, I should write this as a positive. So the net torque will be equals to, this is positive, this is negative, it's a plus 20 Newton into meter. That means wheel is rotating in clockwise direction. I hope this is clear. Did you get this? Did you? Did you get this? Are you sure? Are you sure? Can we do this? Can we? Any doubts? Is there anything? Is there anything? No? Great. Let's work for the next question. So let's have a projectile motion. This is y-axis. This is x-axis. An object has been projected something like this, and it is going to be reach at this point. This is velocity u while making an angle theta. So the question is that let's define two location. This is the first location and this is the second location. First location is at maximum height, that you can understand, and the second location is it is at the point where its journey is over. So they says that find out torque at 1 and 2 with respect to origin. So simply this is the requirement, that I need to find out the torque at position 1 and position 2 with respect to origin. So let's just do it. So do you remember the basics of the torque? Do you remember the very basics of the torque? What does torque require? When I think about the torque, what I understood is that torque requires two things. One, perpendicular distance multiplied by force. So when we think about the projectile motion, when we think about the projectile motion, force would be only the mg that is acting on the total journey of the projectile motion. No other force is acting. So our task is very easy. Our task is very easy, that only one force is acting, and it is acting in the downward direction. Yes, the force mg is always acting in the downward direction. So when I say torque due to 1, I can observe this very easily, that this is the r by 2. This is half of the range. This is half of the range. So this torque 1, it's an range by 2 multiplied by force. Now, if options have given something like this, you can replace the range, which it could be u square sine 2 theta by g into 2 multiplied by mg, and then mg could be cancelled out, and that all stuff, whatever it could be, that has been given in the options. But do you understand the concept behind this? Do you Have you understand the concept behind this? Yes, it is very simple. Always you need to look for this two people only. Yes, you required a perpendicular force. You required a perpendicular force multiplied by distance, or you can just find it out, that perpendicular force multiplied by distance. Find it out, either of these two, and your task has been over. That's it. Well done. Now let's work for the location 2. At this point we require a torque with respect to origin. So mg is the alone force that is acting, and this distance is the range. So torque 2, it's the range multiplied by mg. That's it. Range could be replaced as the u square sine 2 theta divided by g multiplied by mg. This g over, and that could be written as mu square sine 2 theta into Newton into meter. So do you understand this? Do you understand this? Can it be done? Can it be done by you guys? Are you sure? Are you sure? Done? Great. Now let's understand what couple is. It says that when two equal but unlike parallel forces whose lines of action are not the same, that can constitute a couple. And the effect of couple is rotation. So let's understood the situation that this is the point O, where a road AB, let's assume where road AB is hinged. Now at point B, a certain force, perpendicular force, is acting on it, and at point A, a certain perpendicular force is acting on it. Now you can see this very clearly, that at the force acting on the point B will try to rotate the body, and same is the case for the A. So thus A force acting on A and force acting on B is developing a rotational effect on the body. Yes, in this situation, one very important aspect is that if you observe the F net in this body, or you observe F net on this system, then it would be a 0 Newton. Why? Because F Newton, it is acting in the upward direction, F Newton, it is acting in the downward direction. So when and when I considered for the net force, it would be 0 for sure. But it is having net non-zero torque. Let's have a look. Assuming that this is midpoint, so this would be the d by 2. This would be the d by 2. Let's assume this is force 1, this is force 2. Then I will replace it. F1 equals to F2 is equals to F. So when I say torque due to F1, it is F multiplied by d by 2. When I say torque due to F2, it's an F multiplied by d by 2. And due to this both the forces, it is going to rotate it. And the net torque could be written as F into d by 2 multiplied by 2, because such this two forces are, it's an F into D. I hope this is clear. So even though net force is 0, net torque is non-zero. Yes, when we were discussing the conceptual points, we were discussed this point as well, that it it could be possible that net force is 0 but net torque is not 0. I hope this is clear. Yes, great. So this is the couple that we have already derived, that is equals to F into D. They have performed the same thing, F into OA plus F into B, that is equals to F into AB and everything. Yes. Now let's look at the examples of couples we use in our daily life. So we use a couple to turn a door knob. Yes, even opening a door can be considered as one of the couples of the force. Next, to wind the spring in a watch. When we need to wind the spring in a watch, we are going to use the couple. To rotate a screwdriver, to turn a tap, to spin a ball, to turn the steering. This all are the cases where net force may not be zero, but net torque is non-zero. Does it clear? Does it? Is it clear? Great. Now let's look at the one more example. Let's consider a couple acting on a rigid body, and the force is F. One of the forces acting over here, and the other force F acts at a point that is A and B, and the position vectors of A and B with respect to origin, this is origin, is R1 and R2 respectively. So when we need to find out the moment of couple, what I need to do is I need to do just the sum of the moments of the two forces that making the couple with respect to. So what I'm supposed to do is that this is R1, this is F. So what I need to do is I need to find out just the perpendicular distance, that could be written as R1 cross minus of Fa plus R2 cross F. So this could be written as, let's try to solve this, it's an R2 cross F minus R1 cross F, or I should say it's an R2 minus R1 cross F. When I write cross F, that means they are by default perpendicular, but R1 plus AB is equals to R2 and R2 minus R1 is equals to AB. Thus moment of couple, it's AB, moment of couple, this is equals to AB cross F. Yes, this is the perpendicular distance and that force is acting. So it is clear that it is independent of the origin. You can choose origin of your choice. It is the freedom given by the couple to the user, that origin can be chosen of your choice, but you need to find out which kind of torque is acting, which kind of torque is acting. I hope this is clear. Is it clear? Is it clear? Are you sure? Do you have any doubts over this? Is there anything? Are you sure? Are you sure? Are you? Are you sure? Great. Let's just check what is torque acting on a rotating body. Let's have a look. We have a different masses such as mass m1, mass m2, m3 and mn. This is the rotational axis around which the whole body is going to be rotated, and the perpendicular distance from the origin or from the rotational axis due to all these masses are r1, r2, r3, rn respectively. So this is moving in this anti-clockwise direction, and if you observe the linear velocities, I am talking about the linear velocities. If you observe the linear velocity of the particles of each masses that we call as an m1, m2, m3 up to mn, that could be written as v1, that would be equals to r1 into omega, v2 that is r2 omega up and so on, that vn could be written as rn into omega. Yes, these are the linear velocities of each particle. Yes, the each particle of mass m, each particle of mass m is revolving in a circle of radius r with linear acceleration that we can call is as an a is equals to, we have this relation at is equals to r alpha. According to this this a1 is equals to r1 into alpha, because alpha of total body will remain the same. A2 is equals to R2 alpha, and so on AN. That should be AN, that should be written as Rn into alpha. So this is A1, A2 and AN. Now, according to the Newton's second law, we understood that force is equals to mass into acceleration. And when I write acceleration, I am able to write alpha into R1. I'm sorry, F2, it's an M2A2, that would be is equals to M2 into alpha into R2. Same way, this is Fn, that could be written as Mnan, that is equals to this. So when I write this, what what I understood is, that by definition torque is equals to R cross F, or I should say it's a torque equals to Rf sin theta. But in this case all the particles are moving in circular path, and when they are moving in circular path, the theta is equals to 90 degree. That means torque equals to r alpha, r into f, sorry. So when I write this, that torque equals to r into f, and let's put up the value of the f that we have derived in the previous slide, that f was m into r into alpha. I can write this, it's an m1 r1 into r1, this is r1 square into alpha. Same way torque 2, it is m2 r2 square into alpha. Same way torque on the nth particle could be written as mn rn square into alpha. So the total torque acting on the rigid body can be written as torque 1 plus torque 2 plus torque 3 up to torque n, and that could be written as m1 r1 square alpha plus m2 r2 square alpha up to mn rn square alpha. If I combine this, alpha would be the constant. This could be written as m1 r1 square plus m2 r2 square plus m3 r3 square up to mn rn square. So this could be written as something like this. It's a sigma I is equals to 1 to n mi square into alpha. But sigma mi square was the I, which we call as a moment of inertia. So I can prove that torque is equals to I alpha. Same way, it is the same situation that we have when we were discussing and when we were dealing with the force. We have this relation, if you remember, it's F is equals to ma. So this is the linear system, this is the rotational system. Mass is the inertia of linear system, while moment of inertia is the rotational analogous of force. This is the A, acceleration we call it. This is the alpha, we call it as the angular acceleration. So there is a correlations between this two different systems. I hope this is clear. So you can write this, torque is equals to I into alpha. Now let's just look at the few MCQs, and then again we will move to the question answers, numerical question I mean. The question is, the physical quantity analogous to force in translatory motion is blank. In rotational motion, that means the when we use a force in translatory motion, we can use that analogous. In rotational motion, yes, we can use torque to have an analogous with force in translatory system. Let's look at the next question. The dimensional formula for the torque is force multiplied by perpendicular distance. For the force, it's a ma, it's a kg into meter per second square multiplied by meter. This is equals to kg multiplied by meter square per second square. This is m1 l2 t minus 2. The torque tau, That could be written as I alpha. Yes, torque equals to I alpha. This is the correct relation. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Do you understand each and every aspect of this very clearly? Have you? Have you written this? Are you sure? Yes? Great. Let's work for the questions. Let's suppose situation is something like this. This is one of the disc. This disc is having mass, let's say 1 kg, and its radius is, let's say, 1 meter. It is having a pulley kind of effect, and from this disc a rope has been rotated, and one of the end of the rope is at this position. So the question is if you are going to pull this rope by a force of 30 newton. So the question is find out angular acceleration of disk when force is acting as shown in the figure. Yes, this disk has been hinged over here. This disk has been hinged over here, and you are going to apply a force at this position. When you apply a force on this disk will start rotating. I'm talking about the rotating. This disk will start rotating around its hinged point, and we need to find out just the angular acceleration. Always remember, when you require angular acceleration, always look for the torque. I'm not talking that every time you will be having an answer, but most of the time you will have a clue of this, that I can write torque equals to I into alpha. Now disk is rotating like this from omega, and this is the perpendicular distance. So he will provide me the torque. It is the force multiplied by perpendicular distance. Look at this both are perfectly 90 degree, and when they are at 90 degree, it is the maximum torque that is acting on the system. So I can write it's a torque equals to R into F into sine theta. That is equals to I stands for moment of inertia, and here a disk is there. When it is the case of a disk, what we can write is moment of inertia of disk. What is it? Yes, it's an mr square by 2 multiplied by alpha. It's a mr square by 2 multiplied by alpha. So let's just try to solve this. This r has gone, this has gone, and this angle is 90 degrees, so this is f into sine of 90. That is equals to mr by 2 into alpha. Let's just put up the value. This f, it's a 30, sine 90 would be 1. That is equals to mass, it's the 1 kg, radius 1 meter divided by 2 multiplied by alpha. So this is alpha, that should be is equals to 30 into 2, it's a 60. What is the unit of alpha? It's a radian per second square. It is the alpha. I hope this is clear. Is it clear? Is it? So can you do this? Is it? Can it be done? Are you sure? Are you sure? Can you do this? Can it be done? Yes? Great. Now let's work for the next question. Let's say the question says that suppose this is a wheel and it is rotating in this direction. So this is a wheel having mass 5 kg, radius 2 meter. The question says if wheel is rotating at the angular speed of 120 rpm, what amount of torque what amount of torque can can stop the wheel? So what should I do? They says that wheel is already in rotational motion. Wheel is already in rotational motion, and it is moving with the speed, with an angular speed in of 120 rpm. Yes, so I should little change torque can stop the wheel in 10 seconds. Yes, so they want to stop this wheel. How they could stop the wheel in 10 seconds? So what should I do this? Let's first summarize all the things that have given to me. So I'm having a mass, I am having a radius. When mass is there, radius is there, I must assure that I am having a moment of inertia. Yes, what else? It's an omega. It's ideally it is an omega naught. It's a 120 rpm. This is rotations per minute. So let's multiply this by 2 pi by 60. So this is equals to 60 2s are 120. This is 2 pi 2s are 4 pi radian per second. This is omega naught. This is omega naught. The final angular velocity would be 0. So this is omega, that would be equals to 0. Now I have given the time as well. It's a t is equals to 10 seconds. What do I require? I require torque. So what I understand is that always that we have to discuss in the last question as well, that when you require torque, you should look for the torque equals to I alpha. Yes, so if I am, look at this, I am having a mass, I am having a radius, that means I can find out the I. So I would be available, that is for sure. What I required else is the alpha. It's an angular acceleration is required. How will I do this? So if I understand this, that omega naught is given, omega is given, t is given, and alpha is required, so I can do this. It's a omega is equals to omega naught plus alpha into t. Yes, but as this is 0, this is omega naught, which is a 4 pi. This would be a retarding acceleration, that I understand. That is t is equals to 10 seconds. So alpha should be equals to minus of 4 pi divided by 10 radian per second square. Does it clear? So now I am having an alpha 2. Last thing that I want, it's a torque, that is equals to I into alpha. When they said it's a wheel, and wheel would be considered as an analogous to the disk only. Yes, so torque, moment of inertia, could be written as mr square by 2 multiplied by alpha. That m was 5 kg, r is the 2 meter, it's a 4, because it's a 2 square, divide by 2 multiplied by alpha. That alpha would be equals to 4 pi by 10. So this is equals to 2 2s are 4, this is 2 5s are 10, this 5 has gone, and only the torque that remain is the 4 pi newton into meter. Yes, this amount of force, this amount of torque, if applied on the system, if this amount of torque is applied on the system, then this will can come to rest. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Yes? Great. Let's walk for the next question. The question says that a uniform road of mass m and length l can rotate in vertical plane about a smooth horizontal axis hinged at point H. The situation is something like this. This is the road, something like this. Yes, it is being hinged over here at point H, and this length is L. Yes, so this is the situation. Now what do I need? The question is that find angular acceleration of the find angular acceleration of the road just after it released from from initial horizontal position from rest. So how will you do this? First, do one thing, just go through the data, that what they are talking about and what do they want. So what they say is it's a uniform route, it's having a mass of m and length of l, can rotate in vertical plane about a smooth horizontal axis hinged at point H. It has been hinged over here. So find out the angular acceleration, find out the angular acceleration of the root just after it has been released, just after it has been released from the horizontal position. So how will you do this? Do you have any idea over this, that what is to be done, what could be done? What I could understand is that this is the situation. Let me redraw this. This was the situation. Yes, it has been hinged over here. This is H, and this is length L, mass is M, that we understand. Now what you want an alpha. When and when you want alpha, you should go for the torque equals to I alpha. Now who will apply the torque? That is the biggest question. Who will apply it? Who will be? So what I understood is that it has been just in and no other things are acting, but it is having mass m, when it is having mass m, it must be having an mg. Yes, and this is the distance because it's a uniform road. That means the center of mass would be at the midpoint, so it's an mgl by 2. The torque equal to r cross f should be equals to I alpha. When I write the perpendicular distance, it's an L by 2. When I write the force, it's an m into g. That should be is equals to I. Now from where it is rotating, it is going to be rotated from this because it has been hinged over here. This is applying a force and this is applying a moment of inertia. It is rotating at the end point. That could be written as ml square by 3 multiplied by alpha. Just solve this and your task will be done. This ll gone, so alpha could be written as 3g divided by 12. This is the alpha. This is alpha that we call as a radian per second square. Yes, yes. Have you done this? Have you done this? Are you sure? So can it be done by you guys? Can it be? Are you sure? Can we do this? Great. Are you sure? Great. So this is the torque acting on the rigid body. I hope this is clear. So let's just wind it up this session over here. Yes, this was all primary information and primary basic questionnaires based on the torque. As soon as we will be moved further and we will discussing more further about the rotational and rolling motion, we will have certain few more applications that can be opened up with respect to torque. But I want that you people must be clear with up to this. Yes, so please revise this thoroughly. Please have a practice of this kind of questions. Please practice a lot. This will save us. Yes, thank you. Have a good day. Take care. Bye bye.